So, hello. This is the second part second video about OpenCV Project 4 about face mask detection. Last time we talked how train the modules. Today, this video explain how use it and where's the problems which we don't solve, and it's necessary thinking about the future about that. Okay, and first, what I will show you is something as okay. The authorities have a good description of the whole YOLO versions and some process which is possible do with Ultratix library. And there's the one challenge which is very nice in this library because there's some possibilities of exporting the additional format from our application which we won't build. There's some possibilities export to the TorchScript, ONX, OpenWindow, TensorAttack, Corel, M. Yeah, it's this is very nice because this is very easy using because for export we use only model export function with a specific type of export. Yeah, it's very nice and very easy. It's only these few things: model, export, and check you write which format you want. Works fine, but for version 10 it falls. I don't know why, but I think maybe for future it will be better. But in this time, very news last version, YOLO version 10, this type of export for me is not usable because the model is wrong. I can show you where's the problem. For me, maybe we take me some feedback how this problem solved, but for my opinion, I don't know now how to solve it. So okay, the next thing is that I can show you why I won't use ONX format, because the production of software is very interesting using some technologies. And if you won't create model for edge devices, you usually maybe won't use C++ or C, not Python, because the devices as robots and cameras from for this application usually use C++. C. There is C that you use some technologies for OINC format. Interesting is often from web development. Often you train model in Python, but for web use JavaScript and something that what is this is not shown. There's the Julia Rubber Rapi, and next lot of languages have possibilities use ONX model. The next is maybe last language Rust. Rust again, it's in Rust possible use ONX runtime library. and same for very interesting backend language Golang. Then there's the possible use the runtime library or any runtime library too. So this is why we maybe won't use Linux format. So okay, I can show you how work with this format and why some models are not functionality, where is some problems, and some additional information that I check when I testing these things. Okay, so jump to documentation, and now we check this part. We first test ONX models on images. Very simple way is using ultratext library. If you learn model by train model by ultratext library for version 10, 9, 8, and the version 5, if we use these libraries, it's no problem from Python using from production version of software, because ultratext library can use the PyTorch weight file. Again, it's possible to use if you haven't this file and have only Onyx version. This file is possible to use Onyx version, but we must check that this Onyx file is created by Ultralytics library, because the Ultralytics library add some metadata for model models, and if the model haven't this metadata, it usually we have some errors with using the models without this metadata. So this is very interesting. For this kind of solution, you must train model on Ultralytics library way. Okay, so we show how work it. It's very simple. It's again we install library and call the only the YOLO. Then I can load the file. Yes, there is no show. I can maybe, because where is the show? Better maybe this I create by locally, and in GitHub repo is don't show the additional things. Just a minute. This one. Okay. Maybe this is better showing. That there is an image how Ultralytics works. So I take all models, and yeah, there is no show because I must run. Just a minute. Restart kernel. Okay, I can show you. And I use some widgets from picking our type models. So yeah, that's shown. I can show which version of model I want testing, and there's the way I can show this kind of way. Okay, view results. Just a minute. Yes. And you can show results looks very nice. It's perfect. Using this library is only for Python, but the functionality this way is very nice. You can use ONX model, you can use PT models, and the resolution are also very clear and very nice. Yeah, this is the Ultralytics way. It's a very good solution, very effective, and with very nice results. The second thing, what I use is only OpenCV way. OpenCV have a DNM module for working with ONX format, and you can use only OpenCV library. Again, this is the way because OpenCV is for Python and for C++. There's some possibilities and effectively used for edge devices, scam and robots and something, and some production version with developed by Python. But if you want to use for additional languages, you must check how is OpenCV support. I don't know now how, because OpenCV is very good. Often language is supported, but task is how much is create this support, and I don't know. I haven't tested. Uh, okay, so but it's possible to use only OpenCV library from Onyx. Again, we download it. There is not showing again the the I can restart our checking. Okay, I open just a minute and click it. So again, I can select version for my side as this version because this function is very good. I think. Just a minute. The results. Okay. Now we show the results are not same. If you use Ultralytics library, the results will be more better. Why? Because if you use Tech library, Ultralytics library inside is a black box, but there have solved some thresholds, and I don't know, I don't check it, but they solve very effectively way how settings additional things for viewing results and using the models. If you use the ONX model from OpenCV and ONX runtime, you must handle set some thresholds. And this task I show maybe detail on ONX runtime is one which task is a little bit deformate results of this using models, because it's not only about train models, but it's about how this model is using. Okay, I show you. Usually we have two settings, two thresholds. I in this case I use just a minute. Base thresholds 0.5, and there is the second threshold for plotting results. These thresholds filter all the text boxes of YOLO modules. We only take these versions which have probability higher or same as 0.5. We filter it, and next filter is that the thresholds 0.7 filter the duplication of the same boxes on the detections objects. And these settings, it's something what deformate our results, and it's necessary work with this and check in production version of software if you use this way how set these two things more effectively, and how do it the results right way. From my side, I set standard and show how results show for comparing, because I compare with Utartix library, and in this way it's solution worst as result from Utartix. Yeah, there is shown this guy's not detect and this guy's not detect. There is some problems with this 5 people, maybe this one, because if we check on just a minute, ONX Ultralytics version, just you you have detect all, and you have just a minute. Yeah, if we compare 8.4, because this is the, yeah, it's because this is the different version of um, models. I can explain it later. So, and we can show the results are not clear as before, but still are very good. Okay, this is maybe we show in this time, because if we show the results of this is YOLO 5 and this is YOLO 8, the results are better, and this is YOLO 9. You can show the new versions of YOLO are very more effective for detection. The last version was 10 version, and if we use Ultralytics library, 10 version is best. But if you use the additional way how we use models, I don't know, I prefer 8 or 9 version of models. Okay, this is the way how use it the OpenCV library. We show what's in code. There is some function for interference output. You can show there is the transformation, because we use models with version output with necessary transformate. If we use the different 6 version, 7 version, or then we must check it, and these steps don't do it because there is not necessary transfer made the outputs. So there is the some steps for parsed rows, and there's the transformation which is necessary because we use images with different scale for training. So intersection function union, this function is I use from some tutorial. There's this function and this function. You can show these two function is used in there. It's about filtering duplicities of boxes on the results. There's some function for shape detection or some data from shape of images. There's the function for process. Yeah, there's the checking all results of prediction of models. So there's the checking duplicities. There's the function for drawing results, and so this is the base function what I test. But I next steps I use a little bit update function because I download the images as a result, and for review I download. Okay, I can show the boxes results. If you show in data images results, you can show. Okay, OpenCV this. There's two files, CSV files with boxes and class ID and probabilities, which we have with for the results of images. There's the result of image, and there's the description of CSV file. Yeah, you can show what is detect. So then where is it? This way. So this is this function. This function, let's say the image and CSV file data, and there is the image function add for viewing results. This one we show all results of models, which is saved from directory, from comparing and showing what's happened. So this is the, I think, all, and I can show you how work it with last steps. There is a checking image path from all four imaging for testings. There is the output function where is call run interferences, because in this function we create blob and set for net and take predictions. The net is set there. There's the settings of ONX, our ONX form model format. So we create the results of prediction, filter it, we save it and then check it results from directory when we save the results. Okay, this is from way OpenCV using. Last is Oink runtime. Just a minute, maybe maybe one things. I can show you why I can't use the version 10 from this site because okay, if I using just a minute, yes, there is some problems with compatibility. YOLO version 10 Linux model with some DNN library because the models from Analytics have metadata with some parameters, and OpenCV don't know this kind of parameter and false. This is one thing what will be for function must be resolved because we don't use it for this way for using ONX format from Ultralytics export. Okay, this is all maybe. Okay, this. So last way how use it ONX is some combination runtime library and OpenCV library because we use OpenCV or maybe just a minute I must check because it's possible use without OpenCV but we use only ONX runtime and for pre-processing we use only pillow library. This is the way what I used when I want to use Streamlit because Streamlit not support OpenCV compatibilities for that. Because if you use some load widget on Streamlit, Streamlit will support only pillow library, not OpenCV. That the first step we will do by pillow library. So I don't know. So we still again this is same steps from all we and there's the different we set ON extension runtime, we set our selected model, so we get inputs and we can show what's the inputs. We will prepare inputs by pillow library, not by OpenCV. This is the functionality which transfer data from image for using for input by pillow library. We create by function the inputs for model. The next things we create inputs and add this inputs to our list of images. I have name of image and inputs. Next, we check outputs. What's its of outputs ONX format? We can check this kind of outputs. So, and now we prepare inputs, and we create process of prediction and uh, post-processing of prediction from viewing and detection. So first we create outputs. This is the steps where we check name of outputs. Yeah, you can show there's three types of name of outputs. Then we create outputs of models. Yeah, we take input and create outputs. Yeah, this is maybe do some other ways. We automatically load the name of outputs from ONX model and take it there. But I create stuff where I check it and by handle write it. I can show this rebuilding by on version on working with Windows as the better way. So we create some predictions. We add this prediction again to the some dictionary and for next processing. Then we'll process output. We pass off again. We must again create some transformation because we scale images for detection. And there's the next thing. There's the checking because this script is from all version of models. We check it's necessary transformation or not, and we do it that we check two values of outputs format, and we uh, check this values and compare it, and if we uh, some settings we use transformation or not. Yeah. uh, yeah, but is this is I know this is the same, but just a minute. Yeah, yeah. Style font. Okay, this is the yeah middle line. Okay, and this is the different things. I transformation is where. Yeah, this is the what I talk now. This is the about the transformation or not. Let's check if necessary transformate. This is the different things because one problem with exporting of ONX model in one sample, I have problem that the name of class was different. We have set standard class for two class, which was named 0 and 1, but in one sample was set 1 and 2 class name. And this part is part which check these problems. I don't know now where version was this problem. Maybe almost 7 version, but in one version of YOLO is this problem. There is the different settings from class. and this part code is about that from transports the tensor is this version. Okay, so we again check all boxes with our settings thresholds. We must add the name of your classes for next processing of ONX model. We check we there's the settings of thresholds. Yeah, we have biweekly check thresholds, and then we uh, use it for last steps. We create outputs, predictions, boxes, create boxes results, rendering. From rendering, we use color maps. There's the differences between file library and OpenCV. OpenCV, you must uh, check these things different way. In below library, we can do some color maps and uh, take it as inputs to the creation rectangles. So there's the function from drawing by below library, and we can check the results. First, we check without filtering duplicities. Yes, it's interesting because we show maybe in this results are detect, but if we use these steps for filtering, this is the same as before. We create a function from filtering duplicities and use it thresholds value from duplicities. Again, we check. I'll show you. There's a possible settings by widget. We draw again results with outputs, CSV outputs, and we check filtered results. Okay. In this case, it's show how false the yellow version 10 model warnings. You can show this is a very worst version of model. It's not functionality. Yeah, this is yellow version 10. This is again results of testing images. So that this is version 5. This looks like nice, but it's not again it's same as use OpenCV. The detection is not clear as using Ultralytics library. There's the same results because we set the same threshold as we using OpenCV way. The results the same as open if we use OpenCV library. This is the false model of ONX 6 version. Yeah, looks like that. It's horrible. It's not functionality. This is the 7 version. This is the same problem. Not functional model, and maybe there is the some nodes the 7 models ONX this way haven't right number of class. I don't know why. but looks like that only have one class. Okay, so this is the 8th version. That's nice. Yeah, this is work very nice. Yeah, because if you check in the samples, detect same results as Ultralytics library. There is the more effective, but looks like very good. Yeah, this is the last thing, not version, and it's same as 8. And we have problem with this 4 persons, and it still is good, but result from Ultralytics library is better. So this is the detection of images. We use freeway. We show how use it, how specifics this way, and where's the problems. Last things, what we check, it's I think okay, it's documentation. It's this testing videos. We have 2 ways. It's possible use only again only OpenCV. It's possible again using only OpenCV way, but I mm, show you how using OpenCV library with a runtime library. Why I combine this because OpenCV is used only pre-processing of video. Next things it's created by Unix runtime. So the next solution is a solution from Ultralytics and RoboFlow, and I can show you something what is possible. This solution again is possible use if you train models by Ultralytics, but it's very nice and very effective solution, but still is something as black box, and it's only used for Python. This is usable for Python and C++. And if you maybe want to use it, the different languages, if you check how preprocess by OpenCV in this language, the video you can use same steps with Unix runtimes with these languages. So, but code is different with yes. So, okay, first I show this version. This version is created by Kaggle. You can show it Kaggle notebook. And first steps, we a little bit explain this library from RoboFlow. RoboFlow have some open source library called supervision. This library is support for detection on videos. The It's very easy using. You use the Ultralytics library from load models. We use not Unix model, but use the PyTorch models. We set the supervision library from detection and very easy way detect the results. Okay, so how looks like our code? It's very easy. We import libraries, we load models, our models. The models is PT models from Kaggle because I use Kaggle notebook. We create the models from, again, there is some widget for selection. We set path for videos and create some prediction of videos. It's very simple way. This is the how we set on widgets which video we will select again. In this case, we create some from using the RoboFlow library. We create some processing callback, and there's the settings video and only using from processing video. Okay, it's all, and the results are looks like nice. I can show you just a minute. So can open there. Oh, those results. Okay, I can show you the results of detection by this Analytics and the RoboFlow library. Just a minute, which isn't details. Okay, so then first is a video from version 5. You can show as very nice. There detects this funny things. Okay, too. This is nice. This is very interesting from video because in this video it's a good show how version are of YOLO are effective. Yeah, there's this results are very nice, and this is version 5 of YOLO. Yeah, the results is very nice. Okay, the next is version 8 because we trained by Ultralytics version 10, 9, 8, and 5 still show, but in this case you can show there is something wrong, but still but in there's a little bit better results from this case because the model is a little bit better. Okay. The next is the 9 version. The results of these videos are similar. This from this sample is results same, but from for this sample it's a little bit faster. Okay. So last is YOLO version 10. You can show the probability of results are higher, yeah, and which we use the last version of YOLO models, the probability graph. And there's the result on this video. Okay, mm, looks like very nice, very fast. Sometimes, okay. So this was a detection video by using Analytics and RoboFlow. Way we have the next version of, and this is the using combination OpenCV and Unix runtime. Okay, so I open and check code. So first we import some libraries. Again, this is same. We create some selection of model. We create some selection of video. So, but now if we create model, we create model station of Unix runtime. We check inputs in this, and we check outputs, and then we take this inputs name and automatically insert to the detection task. Okay, so when I check it, I don't know, is that no, 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 not now. When I am working with this kind of code, it's possible for different models see their more outputs. If you use detection, usually there will use this kind of outputs, but model version 7 and model version 8 have the next possibilities, and then they have more versions outputs there. We all these outputs have similar or have own name. Detection is usually calls as output, and something different is called different name. So then we load video, then we sell some thing about we use Pickle library for saving our widget selection. So we load the part of video. We set the this kind of video to OpenCV for preprocessing. Yes, we call this video to the OpenCV library. There use some steps for preprocessing. This is steps for saving results. This is the steps for preprocessing images on videos whole frame, because now we preprocess a whole frame of video. You must take class. There's the same way we set the different colors from different class, but we do it by this way. We select color for box by name class, a little bit different way as used by Pill library. Okay, we draw the results. There's the again intersection function union, and this function from filtering the duplicities. There is the function from processing image for ONX model. It's okay. I don't solve the steps with I check it in the version of images detection. I use only write now I use only write functionalities of model, and all models I say same outputs, and then this outputs must be transposed. I don't use the wrong model 10, 6, and 7, which these models have output without transpose function necessaries. Then we create some function from pass rows. We again work with the scale images because it's necessary. Work with this. There is still checking class name. This problem will be still checked. There's the post process function which help us filtering results. First, we have confusion threshold, out threshold. This threshold is for filtering boxes with our right probabilities, and this thresholds check duplicities of boxes detection. And next, we set the widget thresholds 1 and second, and then we have main function which we process the video. It's easy. We create blob by function preprocessing. We run model with taking in outputs. We create boxes from outputs, and we display a frame from boxes, write outputs to the file. There's the possibility to show results from window what happens, but I close it next because this is a very long time process, and I think it's not from testing is good show, but for next processing it's not necessary. So and this is the standard things what we do with OpenCV. Okay, now we show results. I think can show the results. There's the results for YOLO 5, 8, 9 version only because the other models are not functionally good because we now using not PT file but ONX file. So okay, we checked first video. Yeah, the detection on the images it's not. There is some problem with detection there. These guys not detect all time. But this is the thing. So which is because we set some by handle some thresholds, and these steps of processing maybe create differences between these results, alternatives, and our results. Next video, there's detection on this video. You can show it's not effective, same as before. It's detection. It's worst, like very worst. But task is it's possible set some thresholds and have a better solution. I don't know. I don't test it. I use base thresholds 0.5 and 0.7. Model 8. This is a little bit more better. Still, we do not detect this, and still we have problem with guys have face down, and the second video, the results are similar, a little bit better, but it's not same as Ultralytics way. Yeah. So I think usually they use thresholds 0.5 and from duplicity 0.65. We take a little bit higher thresholds. Okay, so and last model is 9. Okay, so similar things is this detection. There's some problems with this one. Okay, and we check this sample testing. It's looks like similar as before. It's not same as before. It's first type of way, and it's I don't know. It's a question how a little bit fix it and do better way. Maybe testing lower thresholds. I don't know. Okay, so this is about creation results and something last things what I maybe show. I don't know if I F prepare, but I can show if I have it. Mark still it. If neutron, yeah, this is interesting. I don't know if you use it. There is a possible if you show PT model, yeah, show how is create this kind of models, or if you use the Onyx model. Okay, we checked Onyx model. Yeah, this is interesting website because you can check what's inside exported models and compared with structure of origin model. Okay, this is the only one thing on the end of video. It's now turned up. Okay, so I think this is everything today. What I explained. This is the end of project 4, and this is the last project what will be do. And for my side is everything. So thank you very much for watching, and maybe later. Okay, bye.